Hi guys, today we're going to take a look at the Unit 1 Classwork packet, page 15, and we're going to look at two harder examples of angle addition and, in one case, maybe some perpendicular and angle bisectors kind of stuff. So we're going to start off by looking at example number 9. Now example number 9 looks kind of terrifying at first glance, right? But what you got to remember is that they actually give you some information on the problem that they haven't yet drawn on the diagram. So my biggest piece of advice to you with these kind of problems, draw the diagram and actually write the stuff they give you in the diagram itself. So they tell me that angle ABF is 6x plus 26. Okay, so ABF. So I'm actually going to write that in right here. So 6x plus 26. So far, so good. Then they tell me that EBF, okay, so EBF, so this itty bitty one right here is 2x minus 9. So let me write that in, okay? And last but not least, they tell me that ABE is 11x minus 31. Okay, so ABE. So that means this big one is 11x minus 31. So look what's really nice about that, guys. By simply writing the information in the problem that they gave us, it turns out that this is actually not a terribly difficult problem. It turns out that this is simply an angle addition problem. Here's a small, and here's the whole thing, otherwise known as a big. So all we gotta do is set up an equation. So I have one of the smalls, 6x plus 26. I have my other small, 2x minus 9, and together they make the big. So what we've just done, by simply drawing the information they gave us in the diagram, we've turned a geometry problem into a multi-step equation from Algebra 1, Chapter 1. Recall, big thing here, guys, because these are on the same side, they're like terms. It's not inverse operations, like terms. So 6x plus 2x is actually 8x. 26 minus 9, is that 17? Hopefully. All right, so then we get down to one of our old trusty favorites here, okay? How exactly are you gonna choose to solve this? My preference would be to get the x's on the right, because then you end up with a positive coefficient for x. So I'm going to subtract 8 from both sides. I get 17 equals 3x minus 31. Because I got all the x's on the right, I'm going to add 31 to both sides. And to get rid of a multiplied 3, divide, and I get x equals 16. Now, of course, the problem, oh my goodness, I'm so sorry. Hopefully you guys can see that. Okay, so the problem here, right, is, well, they didn't ask for that, did they? They asked for angle ABF. So they wanted ABF, they wanted this one right here. So what I gotta do is take that and substitute it back in, right? So just showing that for a moment, I would have 6 times 16 plus 26. So 60 and 36, that makes 96 plus 26. 12 and 110 make 122. Okay? So again, big idea to attack these problems, write the information in the problem. Okay? Can we all hopefully live with that? Okay, so if you need to write this down, you can pause me and copy it down, or, rewind me and play me again. But because the same diagram is actually used for the next problem, I'm going to erase all the work here, but leave the diagram up. Okay? Now we're going to take a look together at example number 10 to see how that would work. All right. Okay, so let's take a look together at example number 10. There we go. All right, so this time they tell me that BD bisects CBE. BD okay, so hold on a second. So CBE, and it says that this bisects. What does bisect mean? It means to split into two equal parts. So what I'm going to do here is draw this little arc symbol and this little arc symbol to remind myself that those two angles are exactly the same. Once again, why was I able to do that? The problem said that BD bisects angle CBE. To bisect is to split into two equal parts. Then they give me this weird statement, BC upside down T, which means perpendicular. BC is perpendicular to BA. Okay, BC is perpendicular to BA. So in that case, I wonder how many degrees that is. Any ideas? And I guess I didn't actually really draw this that well, so I apologize. But technically, it should mean that that's a 90-degree angle. So I'm just gonna write a 90 right there. In your diagram on your paper, it actually does work. I apologize that I can't draw very well. Then they told me that CBD, CBD, they really need to get different letters, don't they? Is 3x plus 25. And they tell me that DBE is 7x minus 19. Okay, so DBE is 7x minus 19. And they're asking me to find angle ABD. So they are asking me to find from ABD. So this like obtuse angle here. Now, of course, the question comes, where exactly do we start? Well, notice something. Remember how we said that this bisects the big angle? And I know that these are the same thing? Well, if these are the same thing, then what do you think I can do with them? Oh my goodness, I can set them equal to each other. So my equation then is 3x plus 25 equals 7x, let me make sure my numbers are right. Yeah, 7x minus 19. Sorry about that. Then, same strategies we talked about before. I would prefer to get the x's on the right because then I end up with a positive coefficient of x as opposed to a negative one, right? So, I know a lot of you are comfortable with the equations, but for a few, this review might help, right? So, I got the x's on the right. I had the 19 back on the other side to collect the constants on the left. Okay, so what is that, 44 equals 4x. Divide both sides by 4, and I get x equals 11. Now, of course, that's not exactly what they're asking us for, because that would make my life too easy. They're asking us for ABD. Well, in order to get angle ABD, here's what I know. I know that I'm going to have to add 90 to whatever this hot mess is right here. So I'm going to take that 11, substitute it back in. So when I do that, I'm going to get 3 times 11 plus 25. That's 33 plus 25, which is 58. So I know that this angle right here is 58 degrees. And that means that if I want this whole angle here, I just got to combine the 90 and the 58. So 90 plus 58, 148 degrees. All right. So again, big piece of advice here. When you have a diagram that's more complex, that doesn't necessarily mean the problem itself is harder. It just means that you have to take the information they give you in the written text, put it in the diagram, and think about how it's going to let you approach the problem. Sometimes, as we saw in the other caves, it's a simple angle addition problem. Other times, as in this case, we had to know what the word perpendicular meant to get that was 90 degrees. And we also had to know that when we have an angle bisector, it splits an angle into two equal parts, okay? But at the end of the day, as long as you guys can set up an equation, combine like terms, and solve for x, you're in pretty good shape to be able to approach the vast majority of these questions.